Okay, in this lecture, we are going to be going over a concept called Bayes' theorem. Bayes' theorem essentially is, we do the probability of A. In other words, if I roll a die, what is the probability that it's going to turn up a 4? That would be the probability of A. Or, for instance, used to um, I used to do some ballooning, right? And I would have lots of different balloons, and some of the balloons would be defective. Um, but the probability of A would be, first of all, I've got blue balloons, I've got red balloons, I've got yellow balloons, and I've got white balloons. And if I mix all of these balloons up, what is the probability that I would randomly grab one particular color? Okay, so I'm going to mix all these up and I'm going to tell you that I've got 10 blue balloons, I've got 15 red balloons, 13 white balloons, and 12 yellow balloons. And the probability that I would grab, so that's a total of 50 balloons, the probability that I would grab one, let's see here, one white balloon would be 13 divided by 50. 13 divided by 50, or the probability would be 0.26. So that would be the probability of A. Now, the question is, what is the probability of A being a good balloon? Because I don't really care about the color of the balloon if the color is not good. Um, if it's a defective balloon. I would be out there making balloons for kids, and all of a sudden one would just pop. And I knew that there were certain colors that were more defective than other colors. For instance, blue could be 1 out of 20 that was defective. Where red might be 1 out of 15 that's defective. Where white would be, 1 out of 2 that's defective. And then yellow would be, my best one with, only 1 out of 30 that was defective. And so I knew that based on the color that a child asked for, that it may or may not, that balloon may or may not pop. So let's take a look at this on a spreadsheet. So I've got, like I said earlier, 10 blue balloons, 15 red balloons, 13 white balloons, 12 yellow balloons. And so I've got the prior probabilities right here. Prior probabilities is the probability of A. What is the probability that I am going to grab one of those colors? And then I have the conditional probability. Okay, if I grab a blue balloon, what is the probability of the balloon being defective if I grab a blue balloon? What is the probability of the balloon being good if I grab a blue balloon? What's the probability of the balloon being defective if I grab a yellow balloon? And what's the probability of the balloon being good if I grab a yellow balloon? Okay, and so you can see what's the probability of B, it being defective or good. And this would be B1, this would be B2, B1, B2, B1, B2, B1, B2. Notice that they all have the same condition there. What is the probability of that if I grab one of these colors? And you can see that's the conditional probability. And then to make the joint probability, that would be saying, what is the probability of randomly grabbing a blue balloon that is defective? Okay, so I've got 50 balloons here. What is the probability that I would grab a blue balloon that is defective? And the way that you do that is you multiply 0.2 by 0.05. And that gives you the probability of you randomly grabbing a blue balloon that is defective, which is 0.01. But the probability of you grabbing a blue balloon that is good is 0.19. So that's how you do the joint probability. And you can put this in a probability tree if you want to. So this right here is a probability tree. You can see there are 4 options. There's blue, red, white, and yellow. The probability of you grabbing a blue balloon, there's 10 blue balloons, is 0.2. The probability of that being defective is 1 out of 20. And you multiply 0.2 by 1 divided by 20, and that gives you a joint of 0.01. And you can do the same for red. Multiply 0.3 by 1 divided by 15, which gives you the joint probability of 0.02, or white 0.26. If you want to know specifically with white, for our purposes in this exercise, I noted that half of the white balloons are defective. Now, are half of the white balloons really defective? No, but we're doing that just for our purposes here. But this is a probability tree that shows you, the probability of A, the probability of B, and the probability of B given A, or the probability of B given A. And then this is the joint probability of A and B given A occurring at the same time. Okay. Now we're going to introduce a new concept called posterior probability. And that's essentially saying, if B occurs, what is the probability of A? So in other words, if I grab a defective balloon, what is the probability that that randomly drawn balloon that happens to be defective, what is the probability that it's blue? Or what is the probability that that balloon is red? Or what is the probability that that balloon is white? Okay, and so the way that we calculate that is by something called Bayes' theorem. Bayes' theorem. And what Bayes' theorem says is you need to take the joint probability of a particular occurrence. Okay, so you take the joint probability of, for instance, the blue defective balloon, and you divide it by all the other B1 occurrences. Okay, so equals, or all the other B1 joint probabilities, equals the joint probability of blue defective divided by sum of the joint probability of it being blue and defective, the joint probability of it being red and defective, the joint probability of it being white and defective, and the joint probability of it being yellow and defective. Now, notice I only did the joint probabilities of the colors and it being defective. So I'm saying, what's the occurrence, or what's the probability of it being blue based out of all of the, defective probabilities. Okay, so, what did I do? Oh, I just had an extra parentheses. So the probability, if I were to randomly have a balloon that is defective, the probability that it is blue would be 0.059. Okay, let's take a look at red. Equals the probability that it is red and defective divided by the sum of blue, let's do sum, blue and defective, red and defective, white and defective, and yellow and defective, and that's 0.119, and then equals the probability of it being white and defective divided by the sum of it being blue and defective, red and defective, white and defective, and yellow and defective, and that's 0.7738. So if I grab a white balloon, if I grab a defective balloon, the probability that that balloon is white is 0.7738. And the reason why is because if you look at this, okay, there's 13 balloons, okay, the probability that that is white is 0.5. Okay, so let's take a look at this really quick. Equals 13 multiplied by the defective, and we can tell that there's probably 6.5 defective white balloons that I have. Okay, and then the red equals 15 multiplied by 0.066. There is one defective red balloon equals 10 multiplied by defective. There's 0.5 blue, and then equals 0.24 multiplied by, actually, that's not what I want. I want 12 multiplied by the defective rate, 0.4. So you can see that there's 6.5 about white balloons that are probably defective. There's probably one red balloon, half of a blue balloon, and less than half of a yellow balloon. So the probability of grabbing a white balloon that's defective is pretty high. And then lastly, let's calculate the probability if I grab a defective balloon that it's yellow. So equals the probability of grabbing a yellow defective balloon divided by the sum of all of the probabilities of defective, let's see here, balloons, comma. Okay, and we can do the exact same thing for the good balloons as well. So equals the probability that you grabbed a good yellow balloon divided by the sum of all of the good occurrences. And that gives you the posterior probability that if you grabbed a good balloon that it would be yellow. Okay, then equals, I'll just do this really quick, divided by and then lastly we'll do blue equals 0.19 divided by sum red, white, and yellow. Okay, so if I randomly grab a balloon that's good, what is the probability that that balloon is blue? And the probability that that balloon is blue is 0.228. If I randomly grab a good balloon, what is the probability that that balloon is red? And that probability is 0.336 and 65. And that's based on, you look at the number of the frequency of occurrence of the red balloons, and then also the probability of it being good or defective. So that is that is Bayes' theorem. And you can see Bayes' theorem right here. I'll zoom in on this so that way you can see it a little bit more. This is saying the probability of A, and you notice there's a little I down there. There's lots of different A's. Okay, so this is over here. This would be A1, A2, A3, A4. Okay. But then this would be B1, B2, B1, B2, B1, B2, and B1 and B2. So what is the probability of, the reason why it's I is because you might want to put what is the probability of A sub 4 given B sub 1? Or what is the probability of A sub 3 given B sub 1? And so for those of you who prefer to do this, in the long equation, you can just know that, there's not necessarily going to be just two in the sum down here in the denominator, two joint probabilities in the denominator. In this particular situation, there's 4 joint probabilities in the denominator and only 1 joint probability in the numerator. So we've got the joint probability of blue being defective in the numerator, and we have the sum of blue and defective, red and defective, white and defective, yellow and defective, all in the numerator, or all in the denominator. So only 1 in the numerator and all of the rest in the denominator. But if you wanted to, you really could say, you could add the two of these together and divide it by all four to say what is the probability of it being red or blue. Red or blue, and you can use the rules of addition for that, and then divide it by all four. So that is Bayes' theorem. I would assume that this might take you a few times to go through, and that's okay. Just keep on working at it, but it's a really good, powerful thing, and there's a lot of applications for it.